Imagine this, a single wind turbine can do the work of many, many trees when it comes to fighting climate change. But just how many trees are we talking about? Coal plants are major contributors to carbon dioxide emissions, one of the key drivers of global warming. But how much carbon dioxide can we avoid by using wind energy instead of coal? And how would that compare to the natural power of forests? In this video, we'll explore how wind turbines can help us reduce carbon emissions, and just how much of a difference one turbine can make. Stick around to find out, it might surprise you. Wind turbines come in various sizes, but how much power can they actually produce? Onshore turbines, those installed on land, typically range from 2 to 5 megawatts. These are the ones you often see in large wind farms spread across open landscapes and hills, each capable of powering thousands of homes. Offshore turbines, however, are even larger. Positioned out at sea, they benefit from stronger, more consistent winds, allowing them to generate between 5 and over 12 megawatts. For our comparison, we'll focus on a typical 4 megawatts onshore turbine and a 10 megawatts offshore turbine. So, we've seen that wind turbines can range from 4 megawatt onshore to 10 megawatt offshore. But what does that translate to in terms of energy production? To understand their impact, let's convert these power outputs into annual energy production. First, let's look at a 4 megawatt onshore turbine. Wind turbines typically operate at a capacity factor of about 35%. This means they produce power at this rate for 35% of the time. If we do the calculations, it generates approximately 12.2 million kilowatt-hours per year. Now, for a 10 megawatt offshore turbine. Offshore turbines have a higher capacity factor, around 40% due to more consistent winds. This means a 10 megawatt offshore turbine produces around 35 million kilowatt-hours per year. These figures give us a clear picture of the energy potential of wind turbines. But how does this energy compare to the carbon dioxide savings? Let's find out. When evaluating the environmental impact of different energy sources, carbon dioxide emissions are a key factor. Let's compare the emissions from coal, oil, and natural gas. Coal-fired power plants emit about 1,000 grams of CO₂ per kilowatt-hour of electricity generated. This high emission rate is due to coal's carbon intensity and the lower efficiency of coal-fired plants. Please note that while some sources cite lower figures, like 400 grams per kilowatt-hour, this refers to emissions from coal's primary energy content. The higher figure of 1,000 grams accounts for the inefficiency of coal plants, where much energy is lost as heat, leading to higher actual emissions per unit of electricity. Oil-fired power plants produce around 800 to 900 grams of CO₂ per kilowatt-hour. Natural gas emits approximately 450 to 550 grams of CO₂ per kilowatt-hour, making it the cleanest among fossil fuels. For our comparison with the wind turbine, we'll use the coal plant as our baseline, given its high emissions profile. While wind turbines do produce some CO₂ during their manufacture, transportation, installation, maintenance, and decommissioning, these emissions are negligible compared to the significant CO₂ released from burning fossil fuels. A single 4 megawatt onshore wind turbine, which generates about 12.2 million kilowatt-hours per year, would save up to 12,200 metric tons of CO₂ annually if used instead of a coal plant. A single 10 megawatt offshore wind turbine, generating around 35 million kilowatt-hours per year, would save up to 35,000 metric tons of CO₂ annually compared to a coal plant. Trees play a vital role in capturing and storing carbon dioxide from the atmosphere. However, the amount of carbon dioxide absorbed varies based on tree species, age, and growth conditions. Here's a look at the CO₂ storage capacity of different tree species per year. On average, a tree absorbs about 25 kg of CO₂ per year. This average helps us compare the impact of tree planting in CO₂ reduction efforts. To illustrate the environmental benefits of wind turbines, let's consider how many trees would be needed to offset the CO₂ savings they provide. A 4 megawatt onshore wind turbine, saving about 12,200 metric tons of CO₂ annually, is equivalent to the absorption capacity of approximately 488,000 trees each year. Similarly, a 10 megawatt offshore wind turbine, saving around 35,000 metric tons of CO₂ annually, corresponds to the CO₂ absorption of about 1.4 million trees per year. But how does this compare to the forest area needed to absorb the same amount of CO₂? Let's take a look at different forest types. Temperate forests absorb approximately 1,000 to 2,000 metric tons of CO₂ per square kilometer per year. Tropical rainforests are even more efficient, absorbing about 2,000 to 4,000 metric tons per square kilometer per year. Mediterranean forests typically absorb between 700 and 1,500 metric tons per square kilometer per year. For our calculations, we'll use an average absorption rate of 1,300 metric tons per square kilometer per year. For a 4 megawatt onshore wind turbine, saving 12,200 metric tons of CO₂ annually, this is equivalent to the absorption capacity of approximately 9.4 square kilometers of forest each year. Similarly, a 10 megawatt offshore wind turbine, saving 35,000 metric tons of CO₂ annually, corresponds to the CO₂ absorption of about 26.9 square kilometers of forest per year. These figures highlight the significant role that wind turbines play in reducing CO₂ emissions, showing how their impact on the environment can be compared to areas of forest. To put it into perspective, the CO₂ savings from 1,000 offshore wind turbines could equate to the carbon absorption capacity of a forest covering an area similar to the complete Sicily, the largest island in the Mediterranean Sea. The table below shows other examples, including Hokkaido in Japan, Cuba, Mauritius, Tasmania, the Big Island of Hawaii and Santorini, illustrating the significant impact of wind energy in comparison to these large land areas. It's also important to note that while most of the CO₂ absorbed by trees is eventually released back into the atmosphere when they die, the CO₂ avoided by using wind energy instead of fossil fuels stays stored underground for millions of years, making it a more permanent solution to carbon reduction. To put it in perspective, a typical 4 megawatt onshore wind turbine is equivalent to the CO₂ absorption of about 500,000 trees, while a 10 megawatt offshore wind turbine corresponds to roughly 1.5 million trees. This illustrates the substantial impact that wind turbines can have in reducing CO₂ emissions and combating global warming. However, it's important to remember that while wind turbines provide significant environmental benefits, trees play an invaluable role in our ecosystems. Beyond absorbing carbon dioxide, trees help cool the environment by providing shade and releasing water vapor through a process called transpiration. They also support biodiversity, improve air quality, and offer numerous other ecological benefits. Both wind turbines and trees are crucial in our efforts to address climate change and create a sustainable future.